Welcome all of you. So I'm back with a video in metals and non-metals here, CBSE metals and non-metals. So this is one of the chapters that you have in science CBSE, all know that. So this is going to be a one-shot video for all important things in this chapter, and after this video you will feel that you are being able to remember this chapter better. So we'll start now. And please watch the video till the end, because till the end I shall be continuously telling you all the types of important questions that keep coming every year, mostly asked questions that keep coming every year from this chapter in the boards. Okay, as I teach the concepts, along with them those important questions will be mentioned all through the video till the end. So please watch the video. So let us start. First, when we talk about metals and non-metals, it's not a very new thing. You have heard about it before in 9th and 8th standard. Now in metals and non-metals, firstly, what are metals and what are non-metals? Okay, now metals are the ones which have either 1, 2 or 3 electrons in the outermost orbit. Okay, on the other hand, non-metals are the ones which have 5, 6 and 7 electrons in the outermost orbit. Okay, so 1, 2 and 3 are metals, which number of electrons in the outermost orbit is when it is 1, 2, 3 they are metals. If it is 5, 6, 7 then it is non-metals. Okay, now what about 4? 4 is generally a metalloid, but then 4 for carbon we consider it as a non-metal. Carbon has 4 in the outermost orbit, but we consider it as a non-metal, but generally 4 goes for metalloids. When we have 8 in the outermost orbit, okay, 8 in the outermost orbit makes inert gases, okay, like neon, krypton, xenon, radon, argon and all that. Okay, they will have 8 in the outermost orbit. So there's one more inert gas which is helium, which has 2 in the outermost orbit. So let us concentrate on these now, metals and non-metals. Now metals are the one which has either 1, 2 or 3 in the outermost orbit. And if I take the example of sodium, okay, which has 11 electrons, okay, in sodium when it has 11 electrons, the electronic configuration becomes this. 2, 8 and 1. Okay, now sodium, in order to come to its octet structure, that is, this was taught in 9th standard, it wants to come to outermost orbit 8. In that case, it wants to leave this. Okay, so this electron is actually a free electron, okay, which is not very tightly bound to the nucleus. Okay, so it moves about freely. Now this is what makes metals a good conductor of electricity. Here also, if you note, some of the metals will be having, like magnesium will be having 2 in the outermost orbit, then that also becomes a free electron which helps in the conduction of electricity. If I talk about aluminium has 3 in the outermost orbit, and aluminium also wants to give it away, okay, wants to donate it, and so aluminium is also a metal. And the reason why these metals are very good conductors of electricity and non-metals are not is because these free electrons in the outermost orbit are the ones which are responsible for electricity. Okay, but if you see here 5, 6 and 7, this is for non-metals. In non-metals, when we have 5, 6 and 7 in the outermost orbit, in order to complete their octet, 5, like nitrogen has 5 in the outermost orbit. Nitrogen ko chahiye 3 electrons, okay, to complete 8. So nitrogen will be looking for 3 electrons. Now what happens? Nitrogen wants to take electrons. Nitrogen को इलेक्ट्रॉन्स लेना है. ये हो गया ऑक्सीजन का आउटरमोस्ट ऑर्बिट में 6 होता है, ऑक्सीजन को भी 2 इलेक्ट्रॉन्स लेने हैं और ताकि उसके पास आउटरमोस्ट ऑर्बिट में 8 इलेक्ट्रॉन्स हो जाए. और फिर 7, this is for chlorine, let's say, and chlorine will also want to take 1 electron and complete its octet. तो इनको अपना ऑक्टेट पूरा करना होता है और इनको देकर अपना ऑक्टेट पूरा करना होता है और इनको लेकर अपना ऑक्टेट पूरा करना होता है. Okay, they want to give and complete their octet, they want to take and complete their octet. Hence, these are the ones which don't have free electrons. They easily don't give electrons because they are ready to take. Okay, so that is what makes non-metals bad conductor of electricity. This free electrons makes metals good conductor of electricity. So this, when I was talking about metals and non-metals, then this is one of the physical properties that I am discussing, that why are metals we know are good conductors of electricity and non-metals are bad. Talking about more physical properties of metals and non-metals, okay, metals and non-metals. So what are the other physical properties of metals and non-metals? Another one is good conductor that we wrote, okay, not just not just electricity but also heat. Bad conductor. Okay, let's come to that second point. This is ductile. Remember ductile? Okay, now ductile is metals can be easily made into wires, whereas this is non-ductile. Non-ductile. Okay, they cannot be made into wires. If you are trying to make the wires out of sulfur, it's going to become a powder. Okay, now 1 point, 2 point, let's talk about the third point. Why do metals have next one is malleable. Malleable, now you all know about this is just a quick recap. Malleable, non-malleable. Okay, this is non-malleable. Why? Because you can beat these into sheets. You can get iron sheets, you can get other aluminium sheets, but you cannot get sulfur sheets, or you cannot get, let's say sheets of phosphorus. Okay, so you can't beat them into sheets. Then metals are sonorous. Sonorous means metals make that typical metallic sound. Okay, non-sonorous. So these are some of the properties. You have done it in the previous classes. Let's talk about luster. Metals have that metallic luster, the shine. Okay, these are non-lustrous. These are non-lustrous. They are not lustrous. Okay, so they will not have that shine. Now, if I talk about this luster, there is one non-metal which is still, it's an exception, but it has one is iodine, which is lustrous, okay, shiny crystals, and the other one is graphite. So these are two of the non-metals which are lustrous. Then let's talk about the state. Generally solids, okay, metals are generally solids, non-metals are not solids, they are generally, non-metals are solids or gases. Like in gases we have hydrogen, oxygen, we have chlorine, we have chlorine and all that. In solids we have phosphorus, carbon, then we have sulfur, a whole lot of solid non-metals are there. Okay, but the only exception here is the liquid one, which is mercury. Mercury being a metal, but still it is liquid. Here also we have a liquid one, which is bromine. So that is the only liquid non-metal. Now they keep asking, the exceptions all the time. That's why I am mentioning it here. So these are few of the properties of metals and non-metals, but then they are physical properties. Okay, physical properties. Now these are, so they are physical properties. Yes, I missed out one more, which is they have high melting point and boiling point, and melting point and boiling point here is low melting point and boiling point. Okay, so these are some of the physical properties of metals and non-metals. Now, what are the few small questions that can come from physical properties? Now, apart from, we talked about iodine, we talked about graphite. Now, what are gallium and cesium? Now, gallium and cesium are also two metals. These have very low melting point. Now, what happens is, if we keep them on the palm of our hands in room temperature, they will become liquids. Okay, they become liquids just with the heat of the palm of our hands. That is enough for them to melt. So, their melting point is that low. Okay, now as compared to other metals. If we talk about carbon, now they can also ask you what are the allotropes of carbon. Okay, which are the allotropes of carbon? So allotropes of carbon is one is diamond, which is the crystalline one. Then we have graphite. Graphite is also crystalline. And then we have diamond, graphite, and then we also have fullerene. Okay. Now, one of the other allotrope of carbon is also amorphous carbon. Okay, that is comes under coal. Things like coal and all. Now here diamond is crystalline and it's the hardest substance known. Hardest. So these can be made hardest substance. Fine. Now graphite is also another one where it is graphite is one thing where it is a good conductor of electricity, good conductor of electricity, and then comes fullerene. So if you talk about graphite, okay, if you talk about graphite, graphite is actually being a non-metal is still a good conductor. This is an exception, and graphite is actually used as electrodes in many electrolytic process. Okay, then comes fullerene, and of course amorphous carbon is also there. Amorphous carbon. Okay, so these are few of the allotropes of carbon. Then diamond is very hard, hardest substance known. Okay, it is used to cut glass also. Okay, now let's talk about few exceptions of metals. Again, few exceptions of metals which are again asked as questions. Soft metals. Okay, so we have some alkali metals. These are called alkali metals. Okay, which metals are these? Like sodium and potassium. Like lithium, sodium, and potassium. Okay. These are some of the metals which are so soft that they can easily be cut with a knife. Okay, so you can easily cut them with a knife. Lithium, sodium, potassium, low densities. Okay, they have very low densities and low melting points. So generally, low density and low melting point. Okay, so generally metals should have high density and high melting point, but here we have low density and low melting point. That is it. Okay, this is what I had to say about the physical properties of metals and non-metals. Now let's take the chemical properties. Okay, physical properties is just by seeing what you see. Okay, what you can understand. Okay, but then how does it react with other things? That will come under chemical properties. Now talking about chemical properties, okay, chemical properties of metals and non-metals. Firstly, this is one thing that can come as a question. Metals form when they combine with oxygen, they form metal plus oxygen. Okay, when metals react with oxygen, they form metal oxides. Okay, they form metal oxides. Now, metal oxides are, when metals react with oxygen, they form metal oxides. Now, I can give you some examples like Na2O, okay, K2O, okay, or even CuO. These are all metal oxides. MgO, these are metal oxides. Now, what are their properties? Okay, these metal oxides are also called basic oxides. Why are they called basic oxides? Because they are basic in nature. Okay, their nature is basic. That means they with acids will behave as a base. So you have to remember that metals with oxygen form metal oxides. Okay, so these are basic in nature. Now another thing is, some of them are alkalis. Some of these basic oxides are not just basic oxides, but they are alkalis. That means they will combine with water to form alkalis. Okay. Now what are these basic oxides, or you can also call them bases? They are basically those oxides of metal which are bases. In general, they are bases, that is they with acids they will give the neutralization reaction, and they are also soluble in water. Okay, so they are water soluble bases. Okay, So like I'll give you one example here. This is plus Na2O plus H2O. Okay, that makes NaOH. Okay, that makes NaOH. Now here if I have K2O, okay, I'm not balancing them. Okay, plus H2O, that is KOH. Okay, so these are some of my basic oxides, and here I have few alkalis which are soluble in water. Okay, then now out of these basic oxides there are few, like one of them is ZNO and another is Al2O3. Now this is also a scope for an important question. These are called amphoteric oxides. Okay, if they ask examples, you should tell ZNO and aluminium oxide. Now why are they amphoteric? They have the acidic as well the basic properties. Okay, they behave as an acid as well as a base. I'll tell you exactly why. Now Al2O3 being amphoteric, okay, now see it is behaving like a base, okay, and then it reacts with AlCl3, okay, and plus H2O. So here it behaved as a base with an acid neutralization reaction. Now you'll see what happens. Okay, now it's going to behave with an alkali. What happens? Now it starts behaving as an acid. Okay, and again NaAlO2 plus water. Okay, so now it is behaving as an acid. That is why it is called amphoteric, and there are many uses of this also. Anyway, so this is the amphoteric nature of Al2O3. So if asked amphoteric oxides, mention these two names. If asked with the equations, show that they are amphoteric, give them these two equations. Okay. Now you'll be noting that when I talked about metals, how do they react with water? Okay, how they react with just now I talked about how metals react with oxygen. Okay, now that was I talked about copper and aluminium. Okay, so those are the ones which react with oxygen, and the reactions are very moderate. But if I talk about sodium, if I talk about potassium, okay, these or lithium, okay, these are the ones which are very highly reactive with oxygen, and they catch fire if exposed to air. Okay, that is why when these are kept in the lab, they are kept inside kerosene in bottles in the lab. Okay, and the teacher has to just take it out and kind of cut out a small piece of it to show its action to the students. Okay, because if a large piece is taken out, that can cause some problem, it can cause a big fire. That is why small pieces actually pinched out or cut with a knife. As I told, these are soft metals. Okay, so these metals are highly reactive with oxygen, and so they are generally they are not exposed to air. Of course, they also form the oxides. Okay, so we'll know more about the activity series of the metals after this. Okay, so as I proceed with the video, I'll tell you more about the activity series of metals. Now, how do metals react with metals plus water? Okay, how do they react with water? How do metals react with water? So here it is metal oxide plus hydrogen. Okay, they form metal oxide and hydrogen when they react with water. Now this reaction, let me take few examples. If we are talking about the very active metals, then what happens? If we talk about sodium with water, okay, this is a very active metal, and that gives Na2O plus hydrogen. Okay, here also this is also a very exothermic reaction, and this happens with cold water. Cold water is enough for sodium. It gives out hydrogen. Hydrogen is an inflammable gas. Okay, and it also gives out a lot of heat. Now this heat with this inflammable gas causes fire. Okay, so that is Why? Sodium plus hydrogen is so this is a very active metal. Sodium with water will give heat and hydrogen, and it causes fire. It's a very vigorous reaction. Let's talk about potassium. Same thing happens for potassium as well. Okay, so that also causes fire. Okay, with cold water only. Now if this oxide is there in the water, further, this oxide, okay, so now you already know that further this oxide will combine with water to form what? NaOH, okay, or K2O will further combine with water to form KOH. So what is the complete reaction? If I write it together, then I can actually write this, that it forms NaOH plus H2, because this one, part 1, second step, here first step for potassium, second step for potassium. So combining it, we can write like this, okay, so we can write this combined, okay, plus of course heat, plus heat. So these come under exothermic reactions. So these come under exothermic reactions, okay. Now if we talk about calcium, okay, so calcium is also a metal, and if we talk about calcium, then calcium does react with water, but then it forms hydrogen also, but then the reaction is less vigorous, okay. Calcium on reaction of water keeps floating on the surface of water. Why does it keep floating? It does not catch fire, because of course the heat given out is less, and so it does not catch fire. But why does it start floating? It starts floating because hydrogen gets formed on the surface of the calcium, and so that makes the calcium piece light, and it starts moving on the surface of the water very fast. So calcium is not that as vigorous as that of sodium and potassium. Lithium of course is very vigorous reaction, okay. So in fact for school level we don't even talk about lithium. Starting from magnesium, okay, now we will be talking about the activity series. Starting from magnesium, it cannot react with cold water because this is less reactive, so cold water is not enough for it. So magnesium also reacts with water, but this time it reacts with hot water, okay. Magnesium will react with hot water, okay, and then it does have the same kind of reaction, but then with hot water, okay, because the reactivity in magnesium is less than that of calcium. Then we have iron. Now if we come down to iron, okay, which is further down in the activity series, then it forms, this reacts with steam. Iron reacts with steam because steam is hotter than water, okay, hot water. Steam is hotter than hot water. Now here Fe3O4, that is iron oxide, plus hydrogen, okay, is it balanced, okay. And then what? And then aluminium also reacts with steam, as aluminium is also less reactive than magnesium, okay. Al2O3 plus hydrogen. So this is how the metals react with hydrogen, starting from sodium, potassium, cold water, calcium, also cold water only, magnesium, hot water, iron and aluminium. It has to react. You have to iron and aluminium will react only with steam, not even with hot water. Then let's come to the even after that we have lead, copper, silver and gold. These are the ones which do not react even with steam, okay. So they just don't react with water. So this is how metals react with water. They react in a certain graded way, okay. They have a certain different ways of reacting depending on the reactivity series of metals, okay. Now here, how do I remember the reactivity series of metals? Let's see. Okay, so in this video I'll stop here because there's a big chapter. In my next video, that will be marked as metals and non-metals part 2, I shall be taking up metals and non-metals, the reactivity of series of metals and non-metals, how they react with acids. Also, with that I will also be taking up what is the metallurgy of metals. Okay, metallurgy of metals, purification of metals, and corrosion of metals. So, and what are electrovalent compounds, what are the properties of electrovalent compounds. So you will get to see in the next video. So keep watching. So if you have liked the video, do not forget to like, share and subscribe, and also don't forget to leave a comment behind. Thanks all of you. Thanks for watching the video. Bye then.